Good morning. We got Q4 week 5 day 2. That's our second day here of work. So let's dive into this thing. First problem, solve this using square roots factoring and completing the square. I'm going to go ahead and I'm just going to get all this onto one side and see what my best option here is. So I'm going to have x squared minus 10x. And we're going to get plus 25. And it equals 0. So look pretty good for being a perfect square trinomial. We've got a perfect square here, perfect square here. And if I just check this real quick, remember that 25 right here needs to be half of this squared, which it is. Okay. And so this one, better square that thing or mess my whole problem up here. So half of that's -5, square it is 25. So this matches, this all fits perfectly, so it's a perfect square trinomial, so we're just going to factor it. So that turns into the square root of that, keep that sign, square root of that, 5, and it's a perfect square, so let's square it. And now you go ahead and it says solve it, so you take the square root of both sides. Okay, so the square root of this is just x minus 5, and there is no positive or negative 0, so it's just 0. So we get x equals 5. Okay, now looking a little bit ahead, we only have one solution here. So kind of connecting that to some things that we've done in the past. If this only has one solution, that means my vertex, whatever it is on the x-axis. Okay. And it also means that my discriminant would be, take a second to think about that, would this have a positive discriminant, a negative discriminant, or would it have a discriminant of 0? Well, if it was positive, it would have 2 answers, so it's not that. And if it was negative, it would have no real answer, so this must have a 0 discriminant. So hopefully you're starting to kind of draw those conclusions now. Those were just extra things that we would typically have done in class right there. Okay, all right, so what's that leave me with? This one right here? All right, moving on to number 2. Solve it any method that I want. Okay, so I'm going to go ahead and clean everything up and let's see what happens. So move that negative 2x squared over. Okay, and that's going to leave me with 7x here. And then I'm bringing negative 16 over with a positive 1, makes negative 15. Okay. I'm going to think carefully about factoring. Got a nice little prime number out there. So I know it's going to be 2x and x if this thing's factorable. Okay. And here I've got some options. I've got this 15 and 1. And I've got 5 and 3. You guys are probably really good at this by now if you've been doing these. Okay. So we just got to combine some things together here to see if we can get it. I know that if I put 5 with 2, that makes 10, and 1 with 3 makes 3. And I can get 10 and 3 to make this 7. So we're going to put 2 times 5 right here. Okay. And then we're going to have our 3 and our 1. 3 and our 1 right here. Okay. And then we need a positive here and a negative here. So one's going to be positive, one's going to be negative. So I need it to be positive here, so that this becomes 10x. And I need this to be negative right here, so this becomes negative 3x. Breaking that down all the way back to the beginning for us right there. Okay, and then you solve each of those and you'll have your equation. So set this part equals 0. A lot of you are good enough to do that mentally. Okay, you would just, that would go to the other side, become positive 3, and then divide by 2. So, but I'm going to go ahead and show out the steps. Okay, and then we get x is equal to 3 halves. And then over here, x is negative 5. It's like a backwards y or something. There we go. Okay. All right, so there's your second one. So what do we get over here? Okay. 3 halves of negative 5. Yep. All right, and then using the quadratic formula to solve. It's actually one of my favorite things. Makes me feel like I'm doing some major algebra here. We got an a value of 6. We have a b value that's not there, so 0, and a c value of negative 150. Now, you can use those really big numbers if you want, but I'm actually going to kind of cheat the system here a little bit. I know that this thing is a lot easier to solve by not using the quadratic formula, but we're going to go for it. Let's see what happens here. I'm going to show you without the quadratic formula first. So we would factor out 6. Okay, so my problem would look like that. And this is a perfect square minus a perfect square. So that's the difference of 2 squares. So then that factors really nicely into this. And we are done. So 6 equals 0, not a solution. We get x is equal to plus or minus 5. I am not going to use the quadratic formula to solve that guy. You guys can go ahead and do it. This is just too fast, and I recognized it. And that's the whole point, to have all those different weapons and recognize, what's what. It's not possible. It's not impossible, but I just don't have a calculator, so I didn't feel like multiplying. All right, so there you go. We get that answer. All right, using the discriminant. Okay, so here's our discriminant right here. B squared minus 4ac. Okay, and we've got an a value of 3, a b value of 6 right here, and c value of negative 1. All right, so let's go ahead and put that in there. So 6 squared minus 4 times 3, and then times negative 1. And all we're checking to see is this come out positive, negative, or 0. So 36. And then negative 4 times positive 3 is negative 12, times negative 1 is positive 12. And that's all the farther I need to go. I don't need to simplify it or anything. So I have positive number here, so it's going to give me 2 solutions when we're done. All right. Write it, the equation of the quadratic form in vertex form. Okay. Now, this was a little trickier for me, okay? But because it's multiple choice, I just kind of work backwards here a little bit. So if you remember vertex form, our vertex is going to come from these particular problems right here. Okay, and this is going to be one of our parts, and this is going to be our other part. Okay, so there's a couple things going on here with this that leads me to know that what we've got here is our vertex. Okay, first of all, we have a positive a value in all of these particular problems. There's a positive 1 right here, so I know that it opens up. Okay, so that this has to be my minimum value. Okay, and then the other thing that lets me know which one is which is the fact that, remember, our vertex comes from the opposite of this as our x value, and the exact same as this as our y value. So this vertex is at negative 2, 3. So the opposite of this is negative 2 and 3. So the answer should be D. Okay. All right, continuing on. The whole opening up stuff, that was just kind of extra information. You did not need it to solve this problem. And then, so now we're back to either adding, subtracting, multiplying, divide these things. So we're multiplying g of x times f of x. Okay, I'm going to kind of go ahead and use this vertical form right here. Okay, and we're multiplying. So luckily multiplying, we can do it in any order. Okay, so we're going to get negative 8 times 2, so negative 16. Negative 8 times negative x squared, so it's positive 8x squared. And you start over again. 2x and 2 is 4x. And then 2x and negative x squared. This has a coefficient, or this has an exponent of 1. So when you multiply same bases, you add the exponents. So it's going to be 2 plus 1, which is 3. So we're going to get negative 2x cubed. And then you just put it in the right order. So here's our first term right here. And knock that guy off. And then our x squareds. X's. And you guys could have done this on the other thing. I'm just reviewing with you here. And negative 16. Okay. So it should be B, right? Yep. All right, continuing on here. Let's get rid of this. All right. So we're going to multiply those together, and then we're going to multiply it by 5. So we're going to take that last answer that I just deleted. Let's see if I can bring it back. Okay. That was that added together? That was multiplied together. Okay. So since multiplying is commutative, we're going to take this answer right here, and we're just going to multiply everything by negative 5. So don't do work smarter, not harder type of situation right here. Okay. All right. So multiply all of that by negative 5, so 10 x cubed, negative 40 x squared, negative 20 x, and positive, is that 80, I think? I don't know, 50 and another 30, so 80. All right. All right, so then we're going to have to type that in. Shift 6 to do exponent there for you. 3, no spaces on any of this. Negative 40 x, shift 6, squared, negative 20x, and positive 80. Okay, so that's how you would type in your answer on that one if you were struggling. Okay. All right, and then determine the solutions to the system. This is just going to be using substitution because we're saying that this system right here, this equation, works together with this system. So every letter is the same value. So this x right here, whatever it is the same value as this x. They represent the same thing. They both represent the number of gallons our car gets, or this represents the total money that I spent on something. This might be a membership at a YMCA and it gives me $100, and this may be a different membership to like Planet Fitness, and it ends up costing $100, and then I would be calculating how long it takes me to get $100 or something like that. So you can do elimination on these, you can do substitution on these, or you can graph them on a calculator and see what they do. Most of these are set up for substitution. They're beautiful. So if this y right here is equal to x squared minus 5, or this y right here is also equal to x squared minus 5. So we're just going to box and ship, if you kind of remember that. So I'm going to box this up, okay, and it's going to replace that y right there. All right, so over here, I will then have, change colors for this problem here, 2x minus 2. When is it the same as x squared minus 5? We're trying to find the points that these two have identical values. And we're going to go ahead and solve. I'm going to move everything to one side and see if this thing's factorable or what. Yeah, I'll leave that over there on the other side because I'm not going to probably have to use the quadratic equation. So move all of this over here. So 0 is equal to x squared, and then negative 2x. And I'll be adding 5, so minus 3. Yep, that one's factorable. So go back to some real basic factoring here for you. Okay, so x and 3 and 1. Okay, and we're going to go with a negative 3 and a positive 1. Okay. And then so we're going to get our x value is equal to 3 and negative 1. Okay, that's not our point. Those are our x values. So I'm going to go to another slide now, and we're going to take these values and we're going to plug it back in to either one of these equations. We're going to plug it into this x right here and solve for y, or plug it in for this x and solve for y. We might as well use the easier one. Okay. So I had an x value of 3 or an x value of negative 1. Okay. And we're just going to plug that into this equation right here. You can organize this how you want. Just keep it nice and organized. I'm going to do both problems at the same time. All right, so I'm just going to rewrite this with this substituted in, and then this with that substituted in. So y will equal 2 times 3 minus 2. And then our other y value will be 2 times negative 1 minus 2. Okay, clean this 2 up there. So that's 6 minus 2, so we get y is equal to 4. And over here we get negative 2 minus 2, negative 4. Okay. So this, my point then becomes the combination of this and this. So when I am at an x of 3, I have a y value of 4. That's one of my spots where they're the same. And then over here, when I'm at an x value of negative 1, I'm at a y value of negative 1. Okay. And depending on what this x represents and this y represents, you would then choose which answer is most applicable for your situation. If we were talking about gym memberships, for example, after 3 days, I would have $4 into it, or it cost me $4. Or 1 month ago was negative $4, which would represent them paying me. So maybe in that case, it doesn't work. Okay. All right. So what do we got here? This one. All right. Yep. All right. Okay. And our last one. How many solutions are there? Okay, it is a system. Okay, it's a nonlinear system. One of this is a parabola, so this is quadratic, and this one's linear. Okay, and all you got to do is answer the question on do they intersect? They do not intersect, so 0 solutions. If this line were to slit up and it just grazes the side of this, it would hit at 1. If it were to slide up again and it would hit at 2, 3 solutions not possible with this particular system. If this was a quartic or cubic where it kind of made like, it did something like this. Okay, you can see I could have 1, 2, 3, 4 solutions to that guy. So we don't have to worry about that. Okay, you might see a picture about it though. So, okay, so no solution, 0 solutions. All right, there you go. Have a good day.